Hi, good afternoon. I'm here to present our study title, Efficient Machine Learning Algorithm for Student Academic Performance Prediction. And this is joint work with Dr. Suhair. Let's start with the outline of this presentation. First, I will present the motivation, then related work, after that the methodology, and the final things, result and conclusion. So here is the motivation for this work. As you know, there are diverse sets of data that are available today in education. Therefore, it's helpful to apply data mining to extract factors affecting a student's academic performance. The academic performance of student is an essential part of education. A student with low academic performance will face many issues, such as a late graduation and even dropping out. So, college administration should monitor their student academic performance closely and support students immediately. One method to achieve that is by predicting student academic performance. By using this method will help college administration to identify and support students at early stages and to make plan to improve the academic performance of student. However, predicting student academic performance accurately can be challenging because there are many factors have been considered that affect the student academic performance, such as academic, demographic, and economic. So our goal is to come up with a system that would predict the student academic performance. And there are four things that we would like to consider. One is create a data set. Create a data set that contains the academic and demographic data of the student in computer science department at the technical college. Second one, build a prediction model to predict student academic performance. Then finding the best predictions, mean absolute percentage error. And the final is identify the most important factors that help to predict the student academic performance. So the most of research focused on academic material and demographic factors. In our model, we focus on academic information and demographic factors. We found that most of the research did not consider the average absence and health status, distance from college, as well as academic features such as assignment, presentation, grade. So here is the proposed approach. We will explain, which includes several steps. As you can see, first one, data collection, data pre-processing, splitting data set, and regression. The data was collected from the computer science department and Trinity Technical College for boys. The sample include 819 instances with 12 features for 199 students. Data pre-processing is an important step in data mining. The purpose of data pre-processing is to convert the data into a suitable form that can be used by algorithms. Three pre-processing steps have been applied to the data set. First one, data, as you can see here, which is handle missing value, encoding the categorical data. The last one, feature scaling. In the data cleaning, to handle missing values, in our data set, several students had grades below 60 of 100, which led to missing value in other columns, and some students had over a 20% average absence. These missing values observation were removed from our data set. On the encoding the categorical data, we have three categorical features as shown on the table, which is health status, distance, own car. The health status feature describes the student's health status, whether he has a disease or not, and the own car describes whether the student has a car or not. These two features are considered a binary value, so we used a label encoder. The last one, which is the distance, describes the expected time to get from home to college. Less than 10 minutes, more than 10 minutes, and less than 50 minutes, and more than 45 minutes. Given our geographical and traffic knowledge in the area in which the college is located, if the student takes less than 25 minutes to reach the college, that implies the student lives in the same city. On the other side, if the expected time is more than 45 minutes, that implies that the student traveled from outside the city. So we combine the first two parts and we get a binary value, one assigned to less than 25 minutes and 0 assigned to more than 45 minutes. Last point, which is feature scaling, and the feature scaling is a method used to normalize a set of data features or independent variables, which leads to speeding up the training phase. We used the standardization technique because it gave lower mean absolute percentage error than other technique. So next is the splitting the data set. To build a machine learning model, we must split the original data set into two phases. The first one, training data, is used to train the model, and the second to test the target value and evaluate the model. We use two validation techniques, which is a holdout 80-20 and k-fold cross validation as shown in the table. The main objective in this slide, the regression algorithm we used, the main objective of the proposed system is the prediction of the student total score based on several academic and demographic features considered as input, and the prediction of the total score considered as output. Different regression algorithms, as you can see, linear regression and support vector machine and random forest, are compared to determine which algorithm is more appropriate. The evaluation matrices were used to compare the performance of all regression model. The table, as you can see, all the supervised machine learning algorithms mentioned in this study were deployed in Python. The accuracy of each model was determined using the performance matrices listed below, mean absolute error and mean absolute percentage error. The table shows the result of the regression models in terms of prediction, MAPE and the MAE. The random forest had the lowest, as you can see on the second row, the random forest had the lowest MABE of 0.023 with MAE of 1.869, and the linear regression model had the highest MAP and MAE. Here in this slide, the idea of the feature importance is to identify the most important features that have significant impact on student academic performance of the dataset. The dataset contains many features, but some of these may not affect student academic performance as shown in the table. It can be observed that the ALIC, which is stand for average lecture, which is average of midterm score, is the highest rank which impact the prediction process, followed by the A lab. Here is analysis of our data. We found that number of students have disease less than the other, as it's shown on the first figure, and the next figure present the number of students traveling to the college. One indicates students from the same city and two outside the city. The next, the third and fourth figure highlight the relation between A-lab and ALIC with final grade, which is all. There is a linear relation between each other. And finally, the last one demonstrate the relationship between the practical and theoretical part of the course. There are positive trends between ALIC and A-lab. If the student get high score in ALIC, that leads to getting a high score in A-lab. Conclusion: we found that random forest is the best model with the lowest MAPE, which is 0.023. And we would like to add more features such as knowledge level of English language, as well as the modern system of study in our country, which is the 3 semester, which is a quarter semester. Thank you for listening. And if you have any question, you are welcome. Thank you.
Thank you. Thank you. Thank you for your wonderful presentation, Dr. Mohanad.